On July 19, 2024, world stopped, at least for a moment. CrowdStrike released the update for their Falcon software. Unfortunately, there was a bug. The bug caused crash of millions of computers all around the world, harming also critical infrastructure. In this video, I'm going to explain in simple terms what happened, why it happened, and if we can do something to prevent this in the future. Just a disclaimer, I'm not a CrowdStrike developer nor Microsoft developer, so there will be a little bit guessing from my side because the official information are still pretty sparse. What is Falcon? Falcon is a software which monitors your computer and protects it against the various cyber attacks or cyber threats. You can imagine it as antivirus software, but in larger scale. The Windows operating system have two main modes of operation. That's a kernel mode and user mode. User mode is something where your application usually runs. You can imagine user mode as sort of sandbox, some environment which is provided by kernel mode for the application to do things. And the kernel mode is as deep as it can be. It can touch everything what you can think of. When the program in user mode crashes, nothing much happened. You are in this simulate sandbox environment, so just the program crashes and that's it. On the other hand, when the program in kernel mode crashes, well, the operating system crashes. And you can see the infamous blue screen if you are talking about Windows. Every operating system have their own way how to inform the user that something like that happened, but the blue screen is associated with Windows. And the reason why the crash happened when something crashes in kernel mode is because that's probably the best thing what you can do in situation like that. You have access everywhere to memory of the all processes. You really don't want to do anything else. Even save the work of the user, which is currently in progress, can be problematic because the work in the memory of the computer can be already corrupted. If you save it, the file will be corrupted. Now let's go back to CrowdStrike and to Falcon. The Falcon sensor, being able to do what it needs to do, it must run in kernel mode. For that purpose, Falcon is a driver. Driver is usually associated with a device, with your graphics card, for instance. There is no physical device associated with the Falcon driver, but because Falcon runs in a kernel mode, it is written as a driver. You might ask, how is it possible that Microsoft let something like that enter their system? There should be some test, right? There should be some process to prevent this. And well, there is. Microsoft offers WHQL certification. That's Windows Hardware Quality Labs, and it assures that the driver is compatible with Windows. Well, here is a problem. The process takes time. And unfortunately, cyber threats are evolving pretty fast. If after finding a new threat and producing new update on a CrowdStrike site, you should wait for another Microsoft certification, the threat could already cause way too much damage. So it works in a slightly different way. You have the driver, the main part of your software, but there are more files coming from the outside. The file which runs in kernel mode is certified, everything is all right. But when there is a new Falcon update, the new files coming from the outside and the certified file touches the new file. And the new file can contain also some executable code. That's a problem. CrowdStrike called this file channel file. And as it happened, channel file 291 contained error. As we mentioned, the CrowdStrike really don't want to wait till the certification process takes place for every single update. And that's probably a good thing. But the risk of running your application in kernel mode should be balanced in proper testing and validation processes on your side. It looks a little bit like the Falcon sensor is trusting these channel files way too much. In software development, generally, you should never trust the input of the user. Everything which might come from the outside should be properly checked before the access. In this case, if the Falcon software would first check the validity of the channel file and don't access it directly, execute some functionality, this probably wouldn't happen. Let me give you an example. If your software accesses, let's say, JSON in some specific format, if there is no validity check, I can alter the JSON in any way I want. And if the program simply expects something and immediately behaves that the file is all right, well, it will crash. It might expect some specific byte in some specific location. And in kernel mode, or system crash. Just the interesting example why you really should check your input before you apply it. Let me tell you about SQL injection. Imagine this simple example. There is a text SQL variable and a select statement which is going to assign some value to it. So I'm trying to choose everything from table users, where user ID is some text user ID input, and the text user ID input is taken from the website. For instance, this code might look alright. Text user ID Pavel, select everything from users where user ID is equal Pavel. I can list all users with the Pavel in their name. That's fine. What if someone writes 42 or 1 is equal 1? This is apparently not a username or user ID, but the backend doesn't know about it, like how it should, right? So what's going to happen is select everything from users where user ID is equal 42 or 1 is equal to 1. This statement will be always true. It returns all rows from the users table. This sort of naive way of doing things should be prevented. You should write it in a way better way. This is the validation of the input. You should first check if it looks like user ID, and if not, you can print some warning instead that, sorry, this doesn't look like user ID. I'm not even going to run this thing. It seems that on Falcon side, this didn't happen. But as I mentioned before, I'm just guessing. You might also ask why Microsoft is alright with running Falcon in a kernel mode. Wouldn't it be possible to write in user mode, develop some API with the communication with the kernel and application? The answer might surprise you. Microsoft tried, and they tried in 2009. Unfortunately, European Union said no to it. The reasoning was clear. If Microsoft would do something like that, but in the same way continue to produce their protection on the kernel level, it would be unfair advantage. So for the third-party application, such as products from CrowdStrike, running in user mode, communicating with kernel only through some middleman, and in the other hand, Microsoft solutions running in a kernel directly, European Union saw this as a problem. Microsoft immediately blamed this situation, but European Union firmly say that that's not their problem, and if Microsoft would agree to have also their solution running in user mode, it wouldn't be an issue. If Microsoft is here to blame, or European Union, I will leave this on you. And that's about it. Windows operates in kernel mode or user mode. CrowdStrike developed their Falcon sensor as a driver running in kernel mode. The driver is accessing external files which are part of the updates, and one of the updates corrupted one of the files. There is probably no validation in a place, so the Falcon software took the file, tried to use it, but unfortunately crashed due to error. The crash took all systems with it and caused the problems for over 8 million computers all around the world. What is spicy? It's impossible to fix those computers remotely. And when the computers are locked behind a BitLocker, that's right another level of difficulty for you. You might see that a lesson for you as a developer. If you are loading external files, consider checking if they are valid. So don't trust external files, they are not going to crash your application. Microsoft proposed applications like that could run in user mode, but European Union was not happy with it, and Microsoft probably refused to implement their own software in the same way running in the user mode, so there was a problem. Hopefully, it's never gonna happen again. That will be all for today. I hope I helped you to understand what happened, and see you next time.